Assalamualaikum and good day. Welcome to CMA422 Structural Design. I am Miss Uda and today we're going to look at example 2 in our structural beam design for reinforced concrete. A simply supported rectangular beam of 7 meter, this is the length, span carries a characteristic that including, okay, therefore this question did I mention it is include the self weight of the beam inside the GK, meaning you don't have to calculate that load sebab dah masuk dalam 12 kN per meter, and QK the imposed load is 8 kN per meter respectively. The beam dimension are breadth 275 and the effective depth D is 450. Assuming FCU, meaning the strength of the concrete, is 30 Newton over mm square, or the concrete grade is 30, C30, and Fy, the characteristic strength of reinforcement, is force is 0, meaning this is a high tensile steel, and Fyv, the strength of the shear reinforcement, is 250, meaning this is a mild steel. Design the bending reinforcement. Okay, first we need to differentiate what's actually the difference between example 1 and example 2. Example 1, what's given is the value of H. However, in example number 2, D is given instead. Okay, there's no H stated in the question. For the dead load GK, it is 12 kN and it includes the self weight of the beam. Therefore, we don't need to calculate the self weight for this example. Right. So we can go straight away to design. We will start with loading. Okay. And calculate the ultimate load. We know that this is the partial safety factors for that 1.4 and imposed load 1.6. So masukkan je terus. No need to calculate the self weight sebab dah termasuk dalam that 12 kN per meter for the dead load. So that is for our loading. From the loading itself, we're going to calculate the ultimate bending moment ataupun maximum bending moment using the formula of WL square over 8. So you just masukkan je the value of W here, right? So that is 29.6 and the length of the beam 7 meter, you will get 181.3 for the maximum bending moment. Next, we're going to calculate the MU because we must make sure that M is less than MU. This is done only for checking sahaja. Right. So 0.156 FCU BD square. So 0.156 times the strength of the concrete, meaning it is given. And B is 275, given also. And the D, right? So kita just boleh ambil straight away dari soalan since it is given. 260.618 times 10 power of 6 Newton millimeter, or it is equal to 260.618 kilonewton meter. And we can compare the value of M and MU. We see that the MU is bigger than M. Therefore, no compression reinforcement is required. So you can just design a singly reinforced concrete beam. Or maybe you mungkin akan tulis M is less than MU. Sama je. Right. Next, we going to calculate the value of K after we have make sure that M is less than MU ataupun MU is bigger than M. K equal to M over FCU BD square. Masukkan je the value of maximum bending moment, which is 181.3 times 10 power of 6. FCU 30, B 275 and D 450 and power of 2. You get 0.109 and just letak dalam the formula for lever arm Z. Okay, so gantikanlah the value of K to 0.109. Then you will get this 0.859. Okay, so kita pun dapat it is less than 0.95 D. So teorinya samalah. Okay, kalau kita dapat 0.59 which is lower than the value of 0.95 D, bila kita kira the value of AS, kita masukkan this value. If we get it bigger, then we will use 0.95D instead to calculate for AS. And lupa juga kita kena make sure that it is less than 0.156 ataupun K prime kat sini, the value of K. And for AS here, the steel area M181.3 times 10 power of 6 Newton per meter divide with 0.95 darab dengan the strength of steel. Untuk main reinforcement, sebab dia bagi Fy. So Fy ni memang kalau dalam soalan memang it refer to the strength of the main reinforcement. Okay, kalau Fyv tu adalah strength of shear reinforcement ya. The value of the Z, okay, sebab kita ada 0.859 D. Therefore D450 replace here and you get 1073.274. What we do next is we going to refer to the table, but first kita must see the question whether there is a given, there is a given assumption which is the diameter for main reinforcement is 20 mm, and the diameter of shear reinforcement or link it is 10 mm. Right, so kita hanya boleh ikut the assumption. Kalau dia bagi 20 mm, then use according to the assumption. So I highlight the table for the cross section area of round bars. So kita akan select lah which section that we going to use ya. Make sure that the AS is lower than the selected section, the area tu ya. So according to the table, okay, we see that the four numbers fulfill the area, okay. 1073.274, 1260 is bigger than this value. Okay, so kalau kita nak pilih tu, make sure janganlah terlampau besar. For example, kalau you ada 1260, dia dah cakap pakai the 20 mm diameter. Jangan pula you saja select 1570. Okay, because it will become design yang tak ekonomi lah. The higher number of bars, okay, sebab bila bar makin bertambah kan, the materials akan bertambah lah. Therefore akan jadi lebih mahal the design, over design. Alright, so here I tulislah for T 20 okay, 4 numbers of bar, 5 tensile steel and 20 mm diameter. Right, so ini dia. And we need to check for spacing, is it okay or not in between bars ni, berapa spacing antara bar tu Right, so 275 is the breadth, and then we have to minus number of main reinforcement. Kita nak tolak ni, right, and then kita minus dengan 2 numbers of shear reinforcement ataupun link ini okay, so kita dah tolak ni, ni dah okay, and then minus dengan the concrete cover which is left and right. So what's left is the one yang warna pink tu, highlighted pink. Okay, since kita nak satu je, what is one of this punya space. Okay, so kita kena bagi 3 lah. Okay, just to make it easier for you to remember, just ambil number of bar minus 1 So number of bar is 4, then minus 1 you dapat 3 lah. It is 41.667, okay, which it is bigger than, tertinggal, HAGG plus 5 mm. Sebab HAGG ni adalah the maximum aggregate size Okay, so 20 mm plus 5 mm here, right? So jadi 25 So make sure it is bigger than this 25. And we need to calculate the value of H since H is not given. Dalam soalan ni dia bagi D. Okay, so dapatkan H supaya kita boleh sketch the beam. H equal to D plus half bar, diameter bar, okay, plus dengan diameter prime plus C. So 450 is the effective depth, 20 is the size of the main reinforcement. Sebab tadi kita select 20 mm diameter kan. Bagi 2 plus dengan the shear reinforcement or link diameter and plus with the concrete cover. Then you get the 495. You can use 495 ataupun kita boleh round up to 500 lah. So mungkin I nak round up to 500, tak ada masalah. So the thing is the concrete cover akan slightly thicken lah. Okay, akan menebal sikit around 5 mm. Tak kisah, tak apa. Okay, as long as jangan terkurang. Kalau I pakai this 500 dan di sini bila I draw dan dia akan jadi 50 mm sebab our total height of the beam will be 500 kan. So 450 times plus 50 it will equal to 500. So look at here. Okay, I have 4 numbers of main reinforcement. I draw like this. And the breast 275. I have a mild steel 10 diameter link ataupun shear reinforcement. The effective depth is 450 and the balance down below it is 50. And for the hanger bar, it is assume saja 2T12 2. Okay, so we are done for example number 2. This is easy bila you dah faham. Okay, thank you so much everyone and have a nice day.